I/O processing involves programs making a request for data and then having operating system services interface with the hardware to actually read or write the necessary data. As a result, one of the things we have to consider with I/O processing is that this is where the operating system must directly interface to the hardware in order to be able to manage these connections. The system programmer will create a definition of the hardware environment, including all of the channels, control units, and I/O devices. This will be used to create an I/O definition file, or IODF. This is used when the system is initialized, and the definitions are used in two places. I/O information for the devices is saved in the ZOS environment so that we can identify, assign, and otherwise control the devices that are in use to ZOS. However, the full configuration information is stored in a separate specialized memory called the Hardware Systems area. This is the area used to coordinate between the ZOS operating system and the System Assist processors mentioned in Module 1. One of the roles of the initiator mentioned in the previous section is to process the job control language and assign devices for the files being used. In this way, when a program is attempting to read or write data, there is a physical connection established between the program and the physical devices being referenced. In addition, when a program is ready to process a file, it issues an open command internally, which causes the operating system to connect the program to the required access methods, which are a set of operating system programs which will generate the necessary hardware commands to communicate with the device. So the access methods will know to generate different commands if the file is on a disk rather than on a tape. This removes the requirement of programmers to explicitly code commands for hardware. When a program wants to read or write data, it issues the appropriate command and the access methods get controlled. This will generate a request to the I/O supervisor in ZOS, which schedules the event for the System Assist processor, or SAP, to handle. Since the SAP is a separate CPU, once it gets the request, it can queue it if there are currently no paths available, or it can select it to run on an available I/O path. It then goes out to the device, performs whatever action is required, and then returns. Upon return, the processor is interrupted, notifying it that this external operation has completed. The SAP processor then schedules an interrupt to ZOS to let the operating system know that the I/O has completed. Once ZOS is notified, then ZOS can post the appropriate program indicating that the I/O request has been completed, and then the program can be ready to run again. This slide shows a series of events that occur when performing the I/O. We will assume that we want to read a record so we can trace the events that occur. We can see the request for I/O begin at the program by event number 1. This calls the access methods, which send the hardware commands to the I/O supervisor. In turn, the SAP processor or channel subsystem is notified, which drives the I/O across the channels to the device. The device performs the operation and signals completion. This results in the channel subsystem being notified of completion and generating an interrupt back to ZOS. At this point, the access methods are notified that the I/O has completed, and the requested data is returned to the application program. Let's now take a brief look at the final element in our overview, resource management. In this section, we will briefly consider how ZOS manages the priority of workloads.